In this video, I will show you the technique called TLC, or thin layer chromatography. It's a very powerful way of analyzing mixtures to see what might be in the mixture. Let's start with 4 compounds. There's some powder in this one and some material in each of these 3. I'm going to refer to these 2 as unknown 1 and unknown 2. This one is a compound called fluorinone. It has a formula C13H8O. And this is a compound called fluorine, obviously related to fluorinone. Don't get confused by the name fluorine. It has nothing to do with the element fluorine. This is obviously an organic compound with a formula C13H10. And these 2 unknowns may contain one or the other or both of fluorine and fluorinone. And this is a good situation for analyzing with TLC. Now, let's start with looking at a TLC plate. This is a modern style of TLC plate. It's made out of flexible plastic. You can see it's shiny on the back. On the front, it has a thin layer of a material called silica gel. It's basically silicon dioxide in a very finely divided form and plated on the surface of this plastic. It also has, if you will notice according to the container, it says F254. What that means is that the material is actually impregnated with a little bit of a material that fluoresces at a wavelength of 254 when that ultraviolet wavelength is shined onto this. In fact, let's take a look at what that would look like under a black light. So this is a not very fancy but very effective way of looking at materials under a black light, and it can be turned on at a short wavelength or at a long wavelength. And I'm simply going to slide my TLC plate under this cardboard box, and I'm going to turn on black light. And if you'll notice in there that the TLC plate is glowing green as long as that black light is on. Once I turn the black light off, it doesn't glow anymore. We will make use of that in a little while at the end of the experiment. In the meantime, going back to our unknowns, that's the fluorine, that's the fluorinone, that's the unknown 1 and the unknown 2. First thing I'm going to do is dissolve each of those 4 solid samples in some acetone. Doesn't take very much, just enough to dissolve the solids. Swirl each of those around until the material in each dissolves, at least to some extent. Let's let those sit for a few minutes and I'll show you the little tool we're going to use. This is what's called a micro capillary. You can see that it's made from a capillary tube, very, very thin piece of glass tubing, and it's been drawn out to a point. We will use this to draw a little bit of each liquid up into the capillary, and then we're going to touch it onto the surface of that TLC plate that I showed you a minute ago. Now, these microcapillaries are available to purchase. They're pretty expensive, so I'm going to show you how you can make your own microcapillaries. At this point, we'll take a little break and go make some microcapillaries. Now that the microcapillaries are made, let's return to our TLC plate, and I will show you that we don't have to use that particular size. That's a very big plate. We only want one that's going to fit into our TLC chamber, which is really just a beaker. And so I'm going to cut it about that width right there. Now notice that this plastic with the coating on it is actually thin enough that we can cut it with a pair of scissors, which is nice because then we can make any size plate that we might want. It used to be that TLC plates were always made on glass, and then of course you had to pretty much stick with whatever size TLC plate the glass happened to be. Now, to prepare a TLC plate, I'm going to take a straight edge and a pencil. Not going to press on it very hard because that silica gel is actually a little delicate and we don't want to knock it off the plate. But I'm just going to make a very, very light pencil line across the bottom of the TLC plate, maybe a centimeter or so above the bottom. Then I'm going to mark on there 4 very light little pencil marks, about equally spaced from the edges and from each other. Not crucial, but roughly equidistant from each other and from the edge of the plate. The next thing I'm going to do is to take one of my microcapillaries that I prepared and a little bit of the standard fluorinone, that's the C13H10. I'm going to draw up a little bit of the liquid into the microcapillary. And then what I'm going to do is to carefully touch the end of the microcapillary to the first pencil mark that I made. And that leaves a little tiny liquid spot, which very quickly dries. And then I'm going to touch it again until that dries, and then touch it again until that dries. So I'm making very small spots. You'll be more successful with your TLC if the spots that you make are very small, and that's partly why we use such small microcapillaries when doing it. Different microcapillaries, because I don't want to contaminate one spot with the other. And I'm going to use my second compound, the fluorinone. That's the C13H8O. And I'm going to touch the microcapillary to the surface again. Draw up a little bit of liquid. This time I'm going to touch the second spot on the TLC plate. Second pencil mark. And let a little liquid run out until it dries, and then do it again. And do it again. And so on. As long as the spots stay small, you can do that pretty much as many times as you want to. And then again, getting yet another microcapillary. I'm going to use my third compound, that's the unknown. And draw a little bit up into the microcapillary. And again, touch it to the plate. That spot got a little bit big. We want to try to keep it as small as possible. Again, it dries almost instantaneously. And do it again. That should be plenty. Draw a little bit up into the microcapillary. And again, touch this time the fourth spot. Spot got a little bit big both times. Hopefully that'll be okay. Okay, now that I've prepared my TLC plate, I will show you how to prepare the actual chamber that we're going to use to develop the TLC plate. It's really just a beaker. Put some solvent in. This is a solvent that I prepared a little while ago. It's 9 parts hexane and 1 part ether. This is one of the complicating parts about TLC is that you really don't know what solvent will work well to do the development unless you try some things. This one I happen to know will work fine, but it's a mixture of hexane and ether, and I just dump that into my beaker and it forms a low layer at the bottom. And I have some aluminum foil here that I will use to cover the beaker with when the time comes, just to keep the solvent from evaporating. And then I will take my TLC plate that I just spotted. I will put it into the beaker so that it stands up, so the bottom of the plate goes under the solvent, but the solvent doesn't come up to the level of the spots at this point. Solvent level should actually be below the level of the spots, and what will happen is the solvent will start to rise through the plate by capillary action, and if there's any materials there, those materials will rise along with the solvent. And I've simply put some tin foil on the top to keep it from evaporating. I don't know if you can see it, but the solvent is rising along the plate. And that will take a little bit of time, and we'll let it go for a while until the solvent front reaches close to the top of the plate. We don't want it to go off the top of the plate. So at this point I'm going to stop the video and I will rejoin you when the solvent front has reached the top of the plate. Hello, I'm back. Notice that at this point the solvent front has risen significantly, several inches above the place where I spotted the unknowns to begin with, still marked by the pencil. And I am back. Let's check the progress now. I think we're probably close to done. So I'll pull the plate out and notice that you can see fairly well where the solvent proceeded to. So pretty quickly here, let's just mark very lightly with a pencil where that solvent front was. That way we'll have a record of how high the solvent went. At this point, we're simply going to let the solvent evaporate off the plate, so I just wave it around carefully so as not to knock any of the silica gel off the plate. And you may notice there are some vague yellow spots on there. That makes sense because one of the compounds that we're analyzing has a yellow color, and if you're lucky, you can simply look at those spots and analyze the situation. But the color is light enough, and the fact that one of the unknowns is a colorless compound. So what we want to do now is move to the black light, and we'll put the plate under the black light, and my goodness, let's take a look at what happened. There it is. The plate shows all sorts of interesting things. What I'm going to do is attempt to circle, or at least mark, the spots on the plate. So before we actually pull that out of here, let's just do a little bit of analysis. Remember that the first spot on the left, was fluorine, and it mostly moved towards the very top where the solvent front was. It's the dot that's on the left that's got a little blue circle in the middle of it. That blue circle, by the way, is fluorescing. It's actually glowing with a different color than the background is glowing, and that's partly why it's called fluorine, because it fluoresces. But it's primarily just that one spot, and that makes sense because it's a pure compound. It does have little traces of other things in it. Those are impurities. You can see on the track on the left that there are a couple of other tiny spots. The second to the left track is the fluorinone, and it has primarily a spot that's about halfway up. And notice that it also has another little tiny spot at the very top. That's probably a little bit of fluorine contaminating the fluorinone. The third track is the unknown, what I refer to as unknown 1, and it looks almost exactly like the second track, which was the pure fluorinone. So unknown 1 is pretty much pure fluorinone. Now notice that the fourth track, that's what I refer to as unknown number 2. Notice that it has two things in it: a dot that looks pretty much like fluorine, and a dot that looks pretty much like fluorinone, although it's smaller than the two, the second and the third track, which were pure fluorinone, and that's because there's less fluorinone in the unknown. But what we've shown by this analysis is that what I'm referring to as unknown number 1 is just primarily fluorinone, and what I'm referring to as unknown number 2 has both fluorinone and fluorine in it. TLC then has done a really nice job of telling us what components there are in a particular mixture. We can, if we wish, because I've circled those spots with a pencil, pull it out, and we can have a semi-permanent record of what the spots were on that plate.